Hello everybody, welcome into another lesson. So today we are going to continue on with our conic sections topic. We are going to talk about parabolas today. So probably everyone's familiar by now with this type of parabola, the classic one that opens upward. This would normally be when we were studying polynomials and quadratic equations and graphing them, this would be of the form y equals x squared. Well, when it comes to doing this in conic section notation, the proper format is actually reversed. You put the quadratic term on the left-hand side and have your linear term on the right-hand side. And the standard form of a parabola with y-axis symmetry, such as what's shown here. This has y-axis symmetry. You could think of the symmetry kind of like a mirror. The y-axis is a mirror. And you could take each half of the parabola, fold it on top of each other, and they would fit perfectly over top of each other. That's the symmetry. So the standard form is this x minus h squared equals 4p times the quantity y minus k. Now, how do you know what axis it's going to have symmetry with just from the equation? It's whatever term is raised to the first power, whichever variable's linear. In this case, y is to the first power, so it's going to have y-axis symmetry. The vertex is at hk, so if I take x minus h, set that equal to 0, I'll get my x-coordinate of the vertex at h. If I take my y minus k, set that equal to 0, I'll get my y-coordinate of the vertex at k. Now, there are two terms to talk about with parabolas, the focus and the directrix, because the exact definition of a parabola is the set of all points equally distant from the focus of the parabola, which is not on the parabola. It's actually outside of the parabola, either above or below. It would be below it if it would open downward. If it opens upward, it's above it. And then the directrix is the line. If it opens upward, it's going to be below the parabola. If the parabola opened downward, it would be above it. They are equidistant, and the vertex actually is halfway between the focus and the directrix. So you're probably wondering, what's this 4p business? Well, usually, of course, h and k will have some numerical value. That 4p represents some coefficient on your y minus k term. So what you have to do is take 4p and set it equal to the coefficient and solve for p. Once you solve for p to find the focus, if it's got the y-axis symmetry, you're going to leave your x-coordinate alone, but you're going to take that p and add it to the y-coordinate of your vertex. That'll be your focus. Then to find your directrix, you're going to take the y-coordinate of your vertex, subtract p from that, and you'll end up with your directrix. The particular parabola I drew is the one that x squared equals y. As you see, the vertex is at 0, 0, the origin. So I would take 4p, set that equal to my coefficient on the y variable, which is 1. I get p equals 1/4. So to find my focus, I would just take that p equals 1/4, add it to my y-coordinate of 0 on the vertex. I get a focus at 0, 1/4. And here's my focus written as f. My directrix, now, I would take that p equals 1/4 and subtract it from the y-coordinate of 0 from the vertex, and you'll just get a line, y equals negative 1/4. So this dotted dashed line below the parabola is my directrix. That's how that works. So we're going to start out with parabolas that have y-axis symmetry. We're going to do a couple examples where the vertex is at the origin, then we'll do a couple where the vertex is not at the origin. So we'll get started on that. Once we do those, the next thing we'll do is where we have x-axis symmetry. So you'll get the full scope of parabolas today. But let's get started with examples of parabolas with y-axis symmetry where the vertex is at the origin. So, for example, I have something like, they might give an equation to you like this: x squared plus 8y equals 0. So they give you x squared plus 8y equals 0. The standard form of a conic section for a parabola, that equation is the quadratic term is by itself on one side, the linear term is by itself on the other. So we have to get the x squared by itself. We have to kick the 8y out of the left-hand side. So if we do that, what you're going to have now is that x squared equals negative 8y. Now you got this in a format you can work with. The first thing you want to do is determine the symmetry. What axis does it have symmetry with? Well, to answer that question again, which variable is only raised to the first power, or which variable is linear? It's definitely the y variable, right? So that means it's going to have y-axis symmetry. Now, the next thing we need to go for is the vertex. Well, you just see x squared. You don't see x minus some number quantity squared. And then with y, you just see a y. You don't see negative 8 times y plus or minus some number. So that means your vertex is at the origin. Alright, so we have the vertex at the origin. Let's go ahead and plot that vertex at the origin there, okay? Now, next thing we need to do is solve for p. So we're going to take for p, we're going to set it equal to that coefficient on the y, which is negative 8. Well, p then would equal negative 2. So p equals negative 2. So let's solve for the focus. I'll just abbreviate that capital F. Now, to find my focus, since it's got y-axis symmetry, I'm going to leave my x-coordinate of the vertex alone. That'll still be 0. But my y-coordinate, I'm going to take that negative 2, add it to the y-coordinate of the vertex. Well, 0 plus negative 2 is negative 2. So my focus is going to be at 0, negative 2. So this should start to become more obvious that it's going to open downward. Alright, so that should become more obvious that it's going to open downward. The next thing we need to do is get our directrix. So the directrix, I'm going to, all I worry about is the y, because we're going to get, since it's got y-axis symmetry, we're going to get an equation in the form of y equals a number. Well, to find the directrix, I take that p and I subtract it from the y-coordinate of my vertex. So 0 minus negative 2, well, that just turns into 0 plus 2, which would give you 2. So the directrix is going to be that line y equals 2. Alright, so I'll go ahead and draw this directrix. It's going to be a dotted line through y equals 2. When you're graphing these, you'll want to draw the directrix. That's also a line, that's also how you'll know which way the parabola is going to face. It'll kind of help guide you, because the parabola can't go above the directrix, or it can't go, if it were opening upward, it couldn't go below it. This is going to open downward, it can't go above it. If you have your vertex, you have the focus below the vertex, you have the directrix above the vertex, that should give you a clue that this is going to open downward. We got the vertex. Why don't we pick out a couple of other points so we get an accurate representation? Let's pick negative 1. Let's pick when y equals negative 1. Okay, so that would give us, actually let's pick negative 2, I'm sorry. Why don't we do that? So we would get x squared equals negative 8 times negative 2, which would equal 16. That would give you x equals both plus and minus 4. So at both plus and minus 4 for x, you'll get a y coordinate of -2. I just want to get a good, accurate picture of what this parabola is going to look like, and it's going to be a big one. That's going to be a big parabola, isn't it? A nice, wide open parabola. Alright, so here's my vertex at 0, 0. Here's my focus at 0, -2. There's my directrix at the line y equals 2. So I now have a full picture of this parabola with my respective vertex, focus, and directrix. And that is how you're going to graph parabolas in general. Now let's do one more that still has y-axis symmetry with the vertex at the origin. Then after that, we'll do a couple that still have y-axis symmetry, but the vertex is not at the origin. That's where it changes a little bit. Okay. We also, let's see, now they're going to trick you here. You're going to have -4x squared equals y. They're going to trick you a little bit. Now, you have the quadratic term and the linear term by itself. That's great. And we can definitely know we're going to have y-axis symmetry because the linear term is the y. So that much is true. We're going to have y-axis symmetry. However, this is not in standard form. In order to make this in standard form, you need to get a coefficient on the x squared of +1. That just means we got to divide both sides by -4. If we did that, you would get x squared equals -1/4 y. Alright, so you have x squared equals -1/4 y. Now we have it in a form we can work with, in standard form. And again, you just have x squared and then you just have a simple y, so that means your vertex is at 0, 0. So we'll get a vertex at 0, 0. Let's go ahead and plot that vertex. Now, from there, we need to solve for 4p. So we've obtained the symmetry, we've obtained the vertex, we have the equation in standard form. Let's solve for 4p. So 4p is going to equal my y coefficient of -1/4. That means that p is going to equal -1/16. So now that I've solved for p, I can find the focus. I'll just call that capital F. Since it's got y-axis symmetry, I'll leave my x-coordinate of the vertex alone. Now, all I do to find my focus, again, take that p and add it to the y-coordinate of the vertex. So 0 plus -1/16 gives me -1/16. So the focus is going to be pretty much right against that here. It's going to be a very small fit. There's my focus roughly. Here's my vertex. Vertex right at the origin. Focus pretty much right below it. And then let's go ahead now and take the directrix. So that's what we want now, is the directrix. Well, it's just going to be in the form y equals because we have y-axis symmetry. So I'll take that -1/16, I'll subtract that from my y-coordinate of the vertex, which is 0. 0 minus -1/16, that's 0 plus 1/16. So that would give me y equals 1/16 for the directrix, which is going to be pretty much right against the axis here. There's my y equals 1/16. I know it's not the best representation, but as you can see, you have the focus, the vertex, and the directrix all in very close proximity to one another. And you'll have that sometimes. Now let's find a couple other points so I can really sketch the shape of this parabola. Why don't we take y equals -1? So the focus is below the vertex, the directrix is above it. That should tell you which way it's going to open. It's going to open downward. So, actually no, let's put in -4 for y. I like to work with whole numbers. If I put in a y coordinate of -4, that's just going to then give me x squared would equal +1, which would give me x equals both plus and -1. So when x is -1, I'll get a y coordinate of -4. When x is +1, I'll also get a y coordinate of -4. So there's roughly what my parabola is going to look like. It's going to be a really skinny thing opening downward. Okay, so again, that's how you would sketch a parabola like that. Now, we're going to do a couple where the vertex is not at the origin, but we still have y-axis symmetry. So it'll be in the form we've been dealing with, but it's going to change a little bit. Now, so we have something like x plus 1 quantity squared plus 8 times the quantity of y plus 3 equals 0. So we've been given x plus 1 quantity squared plus 8 times the quantity of y plus 3 equals 0. Well, this isn't quite in standard form because remember, the coordinates, the quadratic term has to be by itself on one side, the linear term needs to be by itself on the other side. So let's isolate them. This would just turn into x plus 1 quantity squared is equal to -8 times the quantity of y plus 3. Now we got this in a form we can work with. We have x plus 1 quantity squared is equal to -8 times the quantity y plus 3. And the linear term, the linear variable is y. That means it's going to have y-axis symmetry. Alright, so we've obtained that. Next thing we need to do is get the vertex. To get the vertex, you'll take each of these variable quantities, set them equal to 0. If I set x plus 1 equal to 0, that would give me x equals -1. If I set y plus 3 equal to 0, that would give me y equals -3. So the vertex of this parabola would be found at the point -1, -3. So we're looking at right here. There's our vertex of -1, -3. Alright, so the very next thing we need to do is solve for 4p once we've obtained that. So 4p is going to equal that coefficient outside of the parentheses on the y. 4p equals -8, which means p itself would equal -2. Now, since we've obtained p, we can find the focus and the directrix. Let's start with the focus first. So y-axis symmetry means I leave the x-coordinate of the vertex alone, but I need to take that -2 and add it to my y-coordinate of -3, giving me the y-coordinate for the focus being -5. So the focus can be found at -1, -5. There's my focus. Now, let's say I put in here, alright, so the focus would be -1, -5, and then the directrix, let's find that. y-axis symmetry means it'll be in the form of y equals. So I'll take that y-coordinate of the vertex of -3, and from that I'll subtract my p-coordinate of -2, so -3 minus -2, that's -3 plus 2, or -1. So the directrix can be found at y equals -1. So here is going to be that directrix of y equals -1. It should be obvious that once again this is going to open downward. Now we also need to find two other points that are on this parabola to really get an accurate picture of the graph. Why don't we pick y is equal to -3, so then we'll get 0 on the right hand side. So let's pick y equals -3. Alright, so then you'll just get x plus 1 squared is equal to 0. Actually, no. You know what? Let's not pick -3. Why don't we pick y equals -5? There's a reason I'm saying that. So y equals -5. That would give me x plus 1 squared is equal to, if I put in -5 for y, I'll get -5 plus 3 is -2. So you get -5 plus 3 is -2 times -8, that's positive 16. So x plus 1 equals both plus and minus 4. I'll get x coordinates of, let's see, -1 minus 4 is -5. -1 plus 4 is 3. So I would have coordinates of -5, -5. So let's see, 2, 3, 4, 5. There's -5, 5, and then over here is going to be 3, 5. Now let's go ahead and draw this. Another fat parabola. And here is my vertex point at -1, -3. Here's my focus at -1, -5. So that's how I'm going to graph this parabola, this time where the vertex is not at the origin. As you see, it's significantly shifted and it still opens downward. Let's do one more with y-axis symmetry, vertex not at the origin, then we're going to talk about x-axis symmetry parabolas. Alright, so good one. So we have x plus 3/2 quantity squared is equal to 4 times the quantity of y minus 2. So we have x plus 3/2 quantity squared equals 4 times the quantity of y minus 2. This is in standard form. We got something we can work with right off the rip. And the linear variable is y, so again, we've identified this as y-axis symmetry. Alright, so we've identified that. Now, what's the vertex? The vertex, so I'll take that x plus 3/2, set that equal to 0, I'll get x equals -3/2. So that's my x coordinate of the vertex. Now what about my y coordinate? I'll take that y minus 2, set it equal to 0. You just get y equals 2. So the vertex can be found at -3/2 2, which would be right up here. There's -3/2 2. Now, the next thing we need to do is solve for p. So you'll take that 4p, set it equal to that coefficient of 4 outside of the y minus 2, so 4p equals 4. That means p equals 1. Now we can find the focus and the directrix. Well, the focus is going to be, of course, since it's y-axis symmetry, we're going to leave our x-coordinate alone, that -3/2, but that y-coordinate's going to be affected. I'll just take that p of 1 and add that to my y-coordinate of 2, giving me the focus at the ordered pair -3/2, 3. So that would be up here for my focus. Now we can find the directrix. The directrix, I'm just going to take my p equals 1. It'll be in the form y equals because it's got y-axis symmetry. I'll take my p of 1 and I'll subtract that from my y-coordinate of 2, so 2 minus 1 is 1. So the directrix is through the line y equals 1, which should make it obvious that this parabola is about to open upward. So actually, we're not going to have any x-intercepts. We could have y-intercepts, but we're not going to have any x-intercepts. Alright, so we got our directrix line here at y equals 1. There's that dotted line. We got the vertex, we got the focus. Why don't we find a couple of other pairs here? So we'll set y equal to 3. Let's set y equal to 3 and find a couple ordered pairs. Okay, so if I put 3 in for y, that'd give me 3 minus 2, which is 1, right? Well, 4 times 1 is 4. So I'm reduced to x plus 3/2 quantity squared is equal to 4. So x plus 3/2 equals both plus and minus 2. So that would give me x equals -3/2, both plus and minus 2. So -3/2 minus 2, well 2 is 4/2, right? So -3/2 minus 4/2, that gives me x equals -7/2. And then -3/2 plus 4/2, that's positive 1/2. So I'll have x coordinates of -7/2, which is -3.5 right here. And then I'll have x equals positive 1/2 right here. Now I can get a nice, fully accurate picture of this parabola. And there is my parabola. Here's my vertex. Here's my focus. So that's what this parabola is going to look like. It opens upward, but it's significantly shifted because the vertex is at -3/2, 2. Then I have my focus, and then I have my directrix. And I just picked a couple other points to make this curve look more accurate. Alright, so that's it for the y-axis symmetry side. Parabolas can also have x-axis symmetry, which people are probably less familiar with. Now the ones we just did, you notice, were a function technically. If you do the vertical line test, they would pass, but the ones we're about to do will not be a function, which would illustrate that just because it's a parabola does not make it a function. So if you have x-axis symmetry, your equation is going to be in the form of y minus k quantity squared is equal to 4p times the quantity of x minus h. So once again, the linear variable denotes which axis it has symmetry with. In this case, the x is linear to the first power. So this is the standard form of the equation for a parabola with x-axis symmetry. Now your vertex, believe it or not, hasn't changed. It's still going to be at that hk. if you set x minus h equal to 0, you get x equals h. You set y minus k equal to 0, you get y equals k, so your vertex is still hk. That hasn't changed. And to find your focus, that 4p, of course, denotes some coefficient on the quantity of x minus h. Well, you would solve for p. This time, since it's got x-axis symmetry, you're going to add p to the x-coordinate of your vertex, but you'll leave your y-coordinate alone. And then you have a directrix. So let's take the directrix here. All I'm going to do is subtract p from my x-coordinate of h. That would give me h minus p. But since it's x-axis symmetry, you'll get the form of the directrix being x equals h minus p. So you would have a vertical line. So why don't we start with a real simple one here. We're going to have y squared is equal to x. So we just got the basic y squared equals x. We have x-axis symmetry. My vertex would be at 0, 0. I'll go ahead and plot that. So here's my vertex at 0, 0. Now, how about 4p? Let's solve for 4p. Again, that 4p relates to the coefficient on the linear variable. In this case, that'll relate to the coefficient on the x. So 4p equals 1. P would equal 1/4. So now to find my focus, remember, since this is x-axis symmetry, I'm going to affect my x-coordinate of the vertex. I'll add p to the 0. That would give me a focus at 1/4, 0. So 1/4, 0 is right about there. And then to find my directrix, again, it's x-axis symmetry. So it's going to be in the form of x equals, well, I'll take that p of 1/4 and subtract it from my x-coordinate of 0. I'll get x equals negative 1/4 as my directrix. So that's going to be right about there. You get this vertical line through x equals negative 1/4. And of course, let's pick a couple other points here. Let's say I pick x equals 1, that would give me y equals both plus and minus 1. If x equals 4, that would give me y equals plus and minus 2. So now I have a really good full picture of this parabola. As you see, it's kicked over on its side. It actually opens to the right. And then here's my focus. There's my vertex where it stems from. Here's my directrix. So again, your focus you could always think of as inside your parabola. The directrix is always outside the parabola. That's true for whatever axis it has symmetry with. So that is the standard graph of a parabola with x-axis symmetry. Had this been y squared equals negative x, it would open to the left instead of to the right. So, and as we see, if we were to do the vertical line test, this would fail the test. This is not a function because it would fail the vertical line test. But we're going to start out graphing. We'll do a couple with x-axis symmetry where the vertex is at the origin. We'll start easy at first. Then we'll do a couple where the vertex is not at the origin. So let's do some of those. Alright, so what do we got here? We have y squared equals 3x. So we've been given the form y squared equals 3x. This is already in standard form, because the quadratic term's on one side, the linear's on the other. And the linear variable is x, that means we're actually going to have x-axis symmetry then. So we should have x-axis symmetry. And then let's find the vertex. Well, the vertex is a dead giveaway. That'll be at 0, 0. So let's plot the vertex right there, 0, 0. Now, next thing we need to do is solve for 4p. That 4p equals the coefficient on my x variable, the linear variable. So 4p equals 3. So that means p is going to equal 3/4. Now that I've solved for p, I can find the focus and the directrix. So the focus, since it's x-axis symmetry, I'm going to affect my x-coordinate. So I take that p of 3/4, add it to my x-coordinate of 0, I'll get my focus then at 3/4, 0. Which is going to be right about there. So there's my focus at 3/4, 0. Now to find my directrix, of course it's x-axis symmetry, so it's going to be in the form of x equals, I'm going to take that p of 3/4 and subtract that from 0. If I subtract 3/4 from 0, I'll get x equals -3/4 for my directrix. So that's going to put me right about there. There is my directrix. Okay, so it should be fairly obvious now, since the directrix is to the left of the vertex, the focus is to the right of it, that this is going to open to the right. We got the vertex, why don't we find some other points? Find at least 2 other points. Why don't we take when x equals 3? So if x equals 3, I put that in, that would give me y squared equals 9, which would give me y equals plus and minus 3. So when x equals 3, I'll get y equals plus 3, and then I'll also get y equals minus 3. Now I have a very good, accurate representation of this parabola that opens up, or that opens to the right. And then of course here's my focus, here's my vertex, there's my directrix, that dotted line, that opens to the right for y squared equals 3x. Alright, let's do one more where the vertex is at the origin, then we'll do a couple where the vertex is not at the origin. Alright, so we are given x minus 5 plus, we'll do 2 times y minus 4 quantity squared. No, actually, let's not do that, 2. I'm going to tweak it a little bit. Let's do 2 times x minus 5 plus the quantity of y minus 4 squared equals 0. So we have 2 times the quantity of x minus 5 plus the quantity of y minus 4 squared is equal to 0. Well, this is not quite in standard form because the quadratic term and the linear term, again, they need to be on separate sides. So let's kick this 2 times x minus 5 out of the left-hand side. If we did that, this is just going to turn into y minus 4 quantity squared is equal to -2 times x minus 5. Now we have a form we can work with. Alright, so let's go on ahead now and identify the symmetry. The linear variable, again, is the x, so this is going to have... You know what, I didn't want to do that one yet. Hold on. I just realized what I did. I wanted to do one with the vertex at the origin. I went a step ahead. Forgive me. How about this one? X plus y squared equals 0. Well, we need to, of course, this is still not in standard form. We need to kick the linear term out of the left-hand side, move it over to the right. This would just turn into y squared is equal to negative x. Now we have a form we can work with. So sorry about that mix-up. I went a step ahead. But anyway, the linear variable is x. That denotes x-axis symmetry. We'll have that. The vertex, we can look at this and see it's clearly at the origin. So let's go ahead and plot that vertex. Now, next thing we need to do is solve for 4p. That's always the coefficient on your linear term. 4p equals that negative 1 on the x, which means p would equal negative 1/4. Since we have x-axis symmetry, we're going to affect the x-coordinate. So, to find my focus, I'll take that p equals negative 1/4, add it to my x-coordinate of 0, I'll get a focus at negative 1/4, 0. So there's my focus, right about there, negative 1/4, 0. And then my directrix, well, that's going to be then, it's of course x-axis symmetry. It's going to be in the form x equals, but I'll subtract negative 1/4 from that 0. So 0 minus negative 1/4 is the same as 0 plus 1/4. So the directrix will be at x equals positive 1/4, which would put that right about there. So yeah, the focus is always inside the parabola. The directrix is always outside. This should tell you the parabola is going to open up to the left. And if I just put in negative 1 for x, I'll end up with y equals plus and minus 1. So there's a good graph of my parabola just based on those. With my vertex at the origin, my focus at negative 1/4, 0, and you see this parabola opens to the left. Okay, now let's get into the couple that actually have the vertex not at the origin, but still x-axis symmetry. So let's do that problem I started to do. Actually, let's do this. So 4 times x minus 5 plus the quantity of y plus 4 squared is equal to 0. So the vertex is definitely not going to be at the origin, but we need to get the quadratic term and the linear term separated from each other on different sides in order to make this in standard form. So if we did that, you'll end up with y plus 4 squared on the left-hand side is going to equal negative 4 times x minus 5 on the right-hand side. Now we have a form we can work with. So this turns into y plus 4 squared equals negative 4 times the quantity x minus 5. Well, the linear variable is x, so that means this is going to have x-axis symmetry. Alright, so the very next thing we should do is find the vertex. Well, the x-coordinate of the vertex, so if I take that x minus 5, set it equal to 0, I'll get an x-coordinate of 5. If I take that y plus 4, set that equal to 0, I would get y equals negative 4. So my vertex is going to be at the point 5, negative 4. So 1, 2, 3, 4, 5, 1, 2, 3, 4. There's my vertex at the point 5, negative 4. Now, we need to solve for 4p next. 4p, that's going to equal my coefficient on the quantity of the x minus 5 outside of it, the parentheses. So 4p would equal that negative 4, which means p would have to equal negative 1. So now we can find the focus and the directrix. The focus, since it's x-axis symmetry, I'm going to take that p equals negative 1, add it to my x-coordinate of the vertex. So 5 plus negative 1, that turns into 4. So the focus would be at 4, negative 4, which would put me right there. Now, what about the directrix? Well, x-axis symmetry means it's going to be in the form of x equals a number. So if I take that 5 minus negative 1, I would get 5 plus 1, which would give me the directrix is through the line x equals 6. So here's going to be my directrix. Through x equals 6, so this should tell me my parabola is going to open to the left. Now let's find a couple other points to make our lives a lot easier. What if I took, in fact, let's do x equals 4. If x equals 4, I'll put that in here. I would get 4 minus 5, which is negative 1 times negative 4. That gives me positive 4. So if x equals 4, that's going to give me y plus 4 squared equals positive 4, which should give me y plus 4 equals plus and minus 2. So y would equal negative 4 both plus and minus 2. So negative 4 minus 2, that would give me y equals negative 6. Negative 4 plus 2, that would give me y equals negative 2. So when x is 4, I could get a y-coordinate of negative 2. Then I could also get a y-coordinate of negative 6. That's just to help me graph this. And yes, eventually this would intersect the x-axis, but it would probably be a while. But there's my directrix through x equals 6. There's my vertex at positive 5, negative 4. My focus at positive 4, negative 4. So there's our parabola that opens to the left with the vertex not at the origin. Let's do one more like this, and then I got a few problems where we're going to work in reverse actually. The last few problems we're not going to graph at all, we're just going to find the equation, but we got one more exercise here of graphing these parabolas with vertex not the origin and x-axis symmetry. So what do we got for you? Alright, good one. Y squared plus x plus y equals 0. They're trying to throw you a curveball here. They give you y squared plus x plus y equals 0. Well, we see the quadratic variables definitely y. We're going to want to keep that on the left side. We're going to want to get the x out of the left-hand side. Let's start simplifying here, okay? So this is going to initially turn into y squared plus y equals negative x. Well, here's the thing. We want to have this in the form of y minus k quantity squared. How are we going to do that? We actually need to complete the square on the left-hand side. So, completing the square, you'll have y squared plus y. Now, take half of the 1 on the y. Half of 1 is 1/2. If you square that 1/2, you get 1/4. But what you do to one side, you got to do to the other. So the right-hand side would become negative x plus 1/4. Now, the left side would simplify into the quantity of y plus 1/2 squared. Since we completed the square, we got a form we can work with. Now, on the right side, the coefficient on your x itself should always be positive 1. So we need to factor out a negative 1 from both terms. You would end up getting negative of the quantity of x minus 1/4. Now you have this in a form you can work with. So this would turn into y plus 1/2 quantity squared equals negative of the quantity of x minus 1/4. The linear variable, of course, is x. That means this is definitely going to have x-axis symmetry. So that should help us out. Now, what's the vertex? So if I set that x minus 1/4 equal to 0, I'll get positive 1/4 for my x coordinate. If I set y plus 1/2 equal to 0, I would get y equals negative 1/2. So my vertex can be found at the coordinate 1/4, negative 1/2, which would be right about there. There's my vertex. Alright, now, next thing we need to do, solve for p. So take 4p, set it equal to that coefficient of negative 1, which would end up giving you p equals negative 1/4. Now we can find the focus and the directrix. Since this has x-axis symmetry, we're going to leave the y-coordinate alone and change the x-coordinate. So finding the focus, I'll add that negative 1/4 to the x-coordinate of the vertex of 1/4, which would give me 0. Then my y-coordinate stays negative 1/2. So I have a focus at 0, negative 1/2. Now, the last thing I have to do is find the directrix. Since it's x-axis symmetry, it's going to be x equals some number, but I have to take this 1/4 coordinate and I gotta subtract that negative 1/4. So 1/4 minus negative 1/4, that's 1/4 plus 1/4, or 1/2. So the directrix will be through the line x equals positive 1/2, which would put me about right there. So we have a very tight-knit directrix, focus, and vertex all in close proximity to one another. And again, you'll have that sometimes. So what are we going to pick here? Why don't we pick x equals 0? If we pick x equals 0 for some points here, what are we going to get? You would end up getting positive 1/4 on the right-hand side, so you'd have y plus 1/2 quantity squared equals 1/4, which means y plus 1/2 equals plus and minus 1/2, which would end up giving you y equals negative 1/2 plus and minus 1/2. Well, negative 1/2 minus 1/2, that would give you y equals negative 1, and then you'll also have positive 0. So you'll get y coordinates of negative 1 as well as 0. So here's my best representation of what this parabola is going to look like. It's going to be a thin little thing that opens to the left with my respective focus, vertex, and directrix. Alright, so we've graphed parabolas. Let's work backwards now. We're not going to do any graphing through these next exercises, but you're going to be given a couple pieces of information about said parabola, and you're going to have to come up with the equation. So let's start here when initially you're given the vertex and the focus. So the vertex of this parabola is going to be at negative 2, 0. The focus of this parabola is going to be at negative 3/2, 0. And that's all we know about the parabola. So the vertex is at -2, 0. The focus is at -3/2, 0. Well, we definitely want to first know the axis of symmetry. What coordinate is being affected? What coordinate's being affected? What coordinate stays the same? Between these two, the y-coordinate doesn't change at all. Your x-coordinate, however, changes from -2 to -3/2, so that means it's going to have x-axis symmetry. Well, if it's x-axis symmetry, that means that x is the linear variable, y is the quadratic. We can actually start initially forming this equation. It won't be the full equation yet, but we can lay the foundation. So x would be the linear, that means y is the quadratic. So on the left-hand side, notice the y-coordinate of the vertex is 0, so this will literally just be y squared is equal to, we don't know p just yet, so we'll say 4p times, then the x-coordinate of the vertex is -2. If x equals -2, that means this would be x plus 2. So we'll have 4p times x plus 2. Now, what is true about between the focus, between the vertex and the focus? To get from the vertex to the focus, you add p, right? So what I have to do is take -2 plus p, because you got to add p to get to your x-coordinate of the focus. So -2 plus p equals -3/2. Well, that means then that p, if we solve for p, that would equal 2 minus 3/2, which means p would just equal 1/2. And now we actually need to solve for 4p. We solve for p. In order to get the right form of the equation, we need to take 4 and multiply it by p. That means 4p would equal 2. So now once you found your 4p, just substitute that in up here, you'll end up with your final result of y squared equals 2 times the quantity of x plus 2. That would be the equation for the particular parabola that's being referenced, with a vertex at -2, 0, a focus at -3/2, 0. It would be y squared equals 2 times the quantity of x plus 2. Alright, a couple more of these. We have a vertex at, let's see, 3, -3. Then we have the focus at the point 3, -9/4. So we've been given the vertex of this parabola at 3, -3. The focus is at 3, -9/4. What variable does not, what coordinate does not change between the vertex and the focus? The x-coordinate doesn't change, right? That stays the same, but your y-coordinate does change. That means we can establish y-axis symmetry. There's going to be y-axis symmetry, which we know if there's y-axis symmetry, the y is the linear variable, the x is the quadratic. So we can start setting up this equation. The x-coordinate of the vertex is 3. If x equals 3, that means it's going to be x minus 3, then the quantity squared. That's going to equal 4p times, now let's take our y equals -3. That means it would be y plus 3. Alright, so you'll have initially x minus 3 quantity squared equals that 4p times y plus 3. Now, to get from the vertex to the focus, again, we add p, right? So that y-coordinate of -3, we'll add p to that, and that should give us -9/4, which means p would equal 3 minus 9/4. Well, 12/4 minus 9/4 is 3/4. P equals 3/4. For the final form, we need to have 4p. Well, 4p in this case would just be 3. So your final form is going to be x minus 3 quantity squared equals 3 times the quantity of y plus 3. So the standard equation for this parabola would be x minus 3 quantity squared equals 3 times the quantity of y plus 3. Alright, let's change this a bit on you. Yes, we are going to change this a bit. You're going to be given the vertex and the directrix this time. I got 4 more problems total. These next 2 are where you're given the vertex and the directrix. So you have a vertex at 0, 4. The directrix, we'll just call it dir, like director, is going to equal y. That's going to be y equals 2. So the vertex of this parabola is at 0, 4. The directrix is y equals 2. Well, this is actually easier in a way. The directrix is a dead giveaway to what axis of symmetry this is. So right off the bat, we know we have y-axis symmetry. Not y-axis, yeah, y-axis symmetry. Well, y-axis symmetry means that y is the linear variable and then x is the quadratic. We got the vertex at least. If x is the quadratic, the vertex, the x-coordinate of the vertex is 0. This would set up as x squared is equal to some 4p times my y-coordinate. So my vertex, the y-coordinate is 4, so y equals 4. That means it would be y minus 4. So initially we have x squared equals 4p times y minus 4. Now, what is true about getting from the vertex to the directrix? You need to subtract p, right? So that means the y-coordinate of 4 minus p equals my directrix of y equals 2. So 4 minus p equals 2. That just means that p is going to equal 2, but we need to get 4p for the standard form of the equation. So that means then that 4p is going to equal 8. So if I put in the 8 now, we'll have the actual equation for this parabola. You would have x squared equals 8 times the quantity of y minus 4. So the actual equation then would end up being x squared equals 8 times the quantity of y minus 4. Now let's do one more with the vertex and the directrix, then we're going to change it again. Alright, so vertex is found at -2, 1. The directrix is through x equals 1. So the vertex of this parabola is at -2, 1. The directrix is going to be at x equals 1. Well, that again, the directrix is a dead giveaway for what axis of symmetry this is. This is going to be x-axis symmetry. X-axis symmetry helps us establish the form of the equation. That means that x has to be the linear variable, y has to be the quadratic. So we can start setting up this equation. If y is the quadratic, and we know the y coordinate of the vertex is 1, so y equals 1, this is going to be y minus 1 quantity squared is equal to 4p times now what the x-coordinate of the vertex is -2, so x equals -2. This would be x plus 2. So you'd have 4p times x plus 2. Okay, well, how do you get from the vertex to the directrix? Again, you got to subtract p. So you would take that -2 minus p. You'll set that equal to 1 for your directrix. Well, that would just give you p equals -3. But for the final form of the equation, we need this to be 4p. So 4p is going to equal -12. So the actual equation ends up then being y minus 1 squared equals -12 times the quantity of x plus 2. So there's your equation. Y minus 1 quantity squared equals -12 times x plus 2. All right, just 2 more exercises, then we're done with the lesson. This time we're changing it again. The directrix will still be there, but the only other piece you'll be given is the focus. You're going to be given the focus and the directrix. So that changes it yet again, what you're given. So the focus of this parabola is going to be at 2, 2. The focus is at 2, 2. The directrix is at x equals -2. So we have a focus for the parabola at 2, 2. The directrix is at x equals -2. Again, the directrix is a dead giveaway of what axis it's symmetry with. So this is going to then be x-axis symmetry, which we know that means the x term has to be linear, the y term has to be quadratic. So of course we need to find the vertex to really get the form of the equation. Well, it's not as bad as you think. What's true about the vertex in relation to the focus and the directrix? It's halfway between them. It's exactly halfway between them. And it's x-axis symmetry, so that means we only have to worry about the y-axis because, the x-axis rather, because the y-coordinate's going to stay the same at 2. We already know the y-coordinate of the vertex, but what about the x-coordinate? So let's take our x-coordinate of 2 plus that -2, which would be 2 minus 2, and if it's halfway between them for the x-coordinate, you would divide by 2. That's going to give you 0 divided by 2, or just 0 for your x-coordinate. So your vertex can be found at the point 0, and then your y-coordinate stays the same at 2. Now we have the vertex, now we got something we can work with. So x-axis symmetry means the x variable, again, is linear, the y is quadratic. So this would turn into y minus 2 quantity squared is equal to 4p. In this case, if the x-coordinate of the vertex is 0, it would literally just be 4px. Well, okay, let's now just look at the vertex. You can either try to go from vertex to directrix to solve for p, or vertex to focus to solve for p. The choice is yours. Personally, I prefer to go to the focus because I'll get a positive p. So if I take the x-coordinate of 0 plus p, I'll get my x-coordinate of 2 for the focus. Well, that's a dead giveaway that p equals 2. Otherwise, I would have had a negative p and would have had to divide out a negative, which isn't as much fun. So 4p would equal 8. So the actual form of the equation would be y minus 2 quantity squared equals 8x. So the equation for this particular parabola is y minus 2 quantity squared equals 8x. I got just one more, then we're done. Focus and directrix again. That's all we're going to be given, the focus and the directrix. Alright. The focus is at 0, 0. Now this is where you really got to pay attention to what they're giving you. Some people would think, oh, 0, 0, vertex. No, it's not the vertex, it's the focus. The directrix is through the line y equals 4. Okay. Well, that y equals 4, that's a dead giveaway for what symmetry we have. That's y-axis symmetry. Alright, so we got y-axis symmetry. And then you have, of course, the next thing we probably want to do is figure out the coordinate of the vertex. Again, it's true that the vertex is halfway between the focus and the directrix. If it's y-axis symmetry, that means we already know the x-coordinate. That's going to stay 0, but we need to find the y-coordinate of the vertex. The y-coordinate of the vertex, so the focus is 0, and then I take my directrix of y equals 4, so 0 plus 4 divided by 2, I would get 4 divided by 2, which would just give me 2 for my y-coordinate of the vertex. So now I found my vertex to be at the coordinate 0, 2. Now I got a form I can work with since I've found my vertex. Okay, so we've determined it's y-axis symmetry, meaning that the y variable is linear, so the x is quadratic. So the x-coordinate of the vertex is 0, so the left side is just going to look like x squared equals 4p times, what is my y-coordinate of the vertex? That's 2, y equals 2, so this would be y minus 2. Alright, now, again, you have a choice. You can either go from your vertex to your focus and solve for p, or from your vertex to your directrix and solve for p. I'm going to go from vertex to focus every time. So y-axis symmetry, that means we need to figure out for the y variable. So 2 plus p is equal to 0, which would end up giving me p equals negative 2. So 4p equals negative 8. So the final form of this equation would be x squared equals negative 8 times the quantity y minus 2. There is my equation for this particular parabola. With a focus at 0, 0, directrix at y equals 4, the equation ends up being x squared equals negative 8 times the quantity y minus 2. Alright, so that's it for this lesson. Next lesson we're going to talk about ellipses. We will get into those type of conic sections. So I hope everybody has a great day. Take care.